Given two strings s and goal, return true if s can become goal after some number of shifts. What are the shifts that we can make? We can make like moving the leftmost character of s to the rightmost position. Let's go through an example. So in this example, we're trying to make goal from s string. And how can we do that? It says there is only one type of shift that we can make. We can move the leftmost character to the rightmost position. So all I can do is I can move A to the end of the string, leftmost character to the rightmost position. So, and then we can compare this with the goal. And if they are equal, we are going to return true. Otherwise, we are going to return false. Are they equal? No, they are not equal. So I'm going to remove the leftmost character and move it to the end. So are they equal? Yes, they are equal. So we are going to return true. What if we had case like this? So it was something like this, right? We had it like this. And we had A, B, C, D. So let's make a move and see if we can make a goal from S. I'm going to move the leftmost character to the rightmost position, and they are not equal. So I'm going to do the same, leftmost character to the rightmost position. They are not equal. And then I'm going to move the leftmost character to the rightmost position. They are not equal. And the same, leftmost character to the rightmost position. They are not equal. And the leftmost character to the rightmost position. They are not equal. As you see, the length of these two are equal, the characters are equal, but the order matters. And we have iterated over the S string once, and we will not be able to make goal out of it. So we are going to return false. So using this information, what we're going to do, let's see how we can code. The first thing is we are going to deal with a special case. If length of S string is not equal to the goal string, so we know for sure we can return false because they are not equal, so we cannot make goal from S. So we're going to say if their length is not equal, we're going to return false, right? And then what we're going to do, we are going to use a deck from a collections library here. The reason that we are doing that is like time complexity for most of the deck operations are constant. So let's make a queue from S from collections. We are going to call deck, right? And we are going to put S here. We are making another queue for goal, and from collections we are going to call deck, and this time we're going to put goal here. And then what we're going to do, we are going to use a while loop to iterate over this queue, which I'm going to call it QS, and the QS, and compare it with QG. And if they are equal, we are going to return true, otherwise we are going to return false. So we are going to have a while loop equal to the length of S, right? Just one time would be enough. And then what we're going to do, we are going to compare QS with QG, and we are going to say if they are equal, we are going to return true. Otherwise, what we're going to do, we are going to move pop the leftmost character and append it to the end. So let's see how we can do that. QS dot append. What are we going to append? We are going to append the leftmost character. Then deck has a function called pop left. So we are going to pop from left from S and append it to the end of the string. So we're going to pop A and append it to the end. And then we need to I plus 1, have I plus 1, otherwise it's gonna loop forever. And then if none of this is going to be true, we are going to return false. So basically what is happening here, we have made two queues here using which is a double linked list using deck, and then we are going to iterate over every single character of S that we have, and we pop it from the left side and move it to the right side, and we compare the QS and QG, and if they are equal we are going to return true, and if the loop is done and they are not equal, we know they are not going to be equal at all, and we are going to return false. So let's run this code, and it says one argument is given. Sorry, my bad here. So let's see, and as you see it worked, and the time complexity for this space complexity is linear, and the time complexity is constant. We are going to have here, as you see, the double linked list, the deck here has these kind of operations for Python: append, append left, pop, pop left, and so on. And the time complexity, as is mentioned here, it says time complexity of all deck operations is O1 unless we are inserting or deleting from the middle. Thank you.